So this is section 2.2, solving one-step equations. So this is a very important first step in learning how to solve equations. Now I do expect you to actually show all the steps so that we get better at those. And when we have multi-step ones, then they're not as complicated. So before I actually go into this writing part, I want to show a couple examples using some algebra tiles. So here we have the equation x plus 2 equals 5, and they want us to model that. So we have x and positive 2, so 2 positive 1s, equals a positive 5. Now you might see in the middle here, there was an equal sign, and right now it says greater than because I haven't finished setting it up. Once I set it up, good, we're set equal to each other. So the idea of solving equations is we're trying to get our unknown, or our x in this case, by itself. So we have to move some numbers around so that we can get that by itself. So these two positives, I don't want those here. So to get rid of them, I would actually need two negatives. But in equations, if I do something on one side of the equal sign, I have to do that on the other side as well. So if I do minus 2 on the left, I have to do minus 2 on the right. Now, the nice thing, when we do that, the positives and negatives cancel each other out. And we're left with 3 positives. X equals 3 by subtracting that 2 over. Let's see one more. So this one we have x and then minus 3, so we need 3 negatives, equals negative 3, so we also need 3 negatives on that side. Okay, again, we're trying to get that x by itself, so to get rid of the 3 negatives, I need to add 3 positives to that side. But if I do that on the left, I need to also do that on the right side. Okay, and again, the positives and negatives are nice and they cancel each other out. And in this case, they cancel out on both sides, and we'll end up with x equals 0 because there's nothing left over there. Okay, so now that you've seen a couple modeled, let's do a couple examples without the modeling. So, solving using addition and subtraction. This first example, x plus negative 13 equals 10. Now again, I always say we don't want two operations in a row, so plus and negative is the same as minus 13 equals 10. So, to get rid of a negative 13 or a minus 13, I need to add 13 positives to that side so that they cancel each other out. Now if I'm going to do that to the left side of my equal sign, I also need to do that to the right side of my equal sign. So again, the negative 13 and positive 13 cancel each other out, and then we just have 10 plus 13 on the right side, which is 23. So x equals 23. Example number 2. Again, we have x minus a negative 12 equals negative 13. Again, I don't like having two symbols in a row, so two minus signs in a row actually make a plus sign. So it says x plus 12 equals negative 13. Now again, we're trying to get this x by itself. Okay, so to get rid of positive 12s, I need 12 negatives to cancel those out. But if I do that on the left side of my equal sign, I also need to do that on the right side. So again, the positive 12 and negative 12 cancel, and I'm just left with x on the left. And on the right, negative 13 minus 12 more. So they're all negatives, so remember we're combining integers. Adding these all together, I'm still going to have negative. 13 and 12 makes 25, so I have negative 25 when I combine those together. Now the last one, the variable's on the right side, and it's not x, but that's okay. You can use any letter for a variable. And the variable does not have to be on the left side of the equation. So the same rules apply. We have p plus 16. Now to get rid of the positive 16, I need to have negative 16 to cancel that out. Now if I do that on the right side of the equal sign, I also need to do that on the left side of the equal sign. So again, positive 16, negative 16, they cancel each other out. Okay, and the negative 12 and negative 16 we need to combine together to get negative 28. So P equals negative 28. Now if you don't like it written negative 28 equals P, you can flip that around so the P is first. It doesn't really matter. Okay, so that was solving using addition and subtraction. Because addition and subtraction are inverse operations, they undo each other. And so the next thing we're going to talk about is solving using multiplication and division, because multiplying and dividing also undo each other. So this first example, we have x divided by 4. Okay, so opposite of division, its inverse operation is multiplication. So to get rid of divide by 4, I have to multiply by 4. But if I do that on the left side, I also need to do that on the right side. Now the divide by 4 and the multiply by 4, they cancel each other out because one's in the numerator and one's in the denominator. And so I'm just left with the x on the left side. And I have 2 times 4, which is 8. Now this next one is 2/3 times p. So you would think I'm going to divide by 3/2 on both sides, which technically is true, but remember, when we divide by fractions, we don't leave them like that. We don't leave them with division. We actually multiply by the reciprocal. So instead of dividing by 2/3, I'm going to multiply by 3/2 on both sides of my equation, because that's how I divide fractions. I multiply by the reciprocal. So on the left side, the 3 cancels the 3, the 2 cancels the 2, so that's again how that works. And so p is left by itself. Okay, on the right side, remember to multiply fractions, we multiply straight across, so 1 times 3 is 3, and 2 times 2 is 4. So p equals 3/4. Alright, this last example, we have 39 equals negative 3 times r. So remember, when things are right next to each other, that's multiplication. So to undo that multiplication, I'm going to have to divide both sides. Now write your division with your fraction bar. So I'm dividing by negative 3, so I can get rid of the negative 3 that's there. Because negative 3 divided by negative 3 is 1, so we end up with 1r, or just r left on the right side. And then 39 divided by negative 3 is negative 13. Okay, so that's all there is to solving one-step equations. If it's addition and subtraction, those will undo each other, and use those inverse operations. Multiplication and division again undo each other. Just be careful with fractions. Remember, when we're dividing fractions, we multiply by the reciprocal.